In section 2.2, we are reviewing the practice of drawing or sketching or graphing linear equations. And we're going to talk about a couple of different forms of linear equations that are typically that we'll be seeing in today's lesson that we'll be graphing from. Starting with this first example, you may remember from Algebra 1, you were exposed to a linear equation form known as SlopeIntercept Form. And just using variables, SlopeIntercept Form is always solve for y, of course. And the number, this number m, this coefficient for m, will always be the slope. So right away, I'm recognizing that with this first example, the slope of this line will be 3/4. And then this b number is understood to be the y-intercept. All right. And relating to this first example, there is no b number showing. And so obviously it's understood that the y-intercept is 0. So I just want to let you remind you that you can think of the b in this equation form as the beginning, and we always begin by plotting whatever this number is on the y-axis. And I know some people get a little turned around and they plot this number on the x-axis. And if that's something that you have trouble with, make sure you focus really hard on this lesson and train yourself to get out of that bad habit. This number that we call the b, the y-intercept, is just that. It always plots on the y-axis. So since it's 0, here is 0 on the y-axis. And now I'm going to focus on the coefficient of x, which we call the slope. And I'm going to count. Remember, another way of thinking of slope, we use the expression rise, which is an up or down. You could be a negative or a falling down, which is like a negative rise. And underneath that is the run, or the left right. So always think of this top number as either going up or down, and the bottom number is how we're going to move left or right. All right, so to do a 3/4 slope, I'm going to go back to this point that we've identified as the y-intercept, and I'm going to look at the top number of this fraction, which is the up or down, and I'm just going to go up 3. Stay there for just a second. And then the bottom number tells me to go right, since it's positive, right 4. You notice that both of those numbers are positive, and so to get a positive fraction, I need a positive number over a positive number. But think about this. To get a positive fraction, isn't it also true to have a negative divided by a negative? Sure it is. And so I could have done the same thing by using 2 negatives. I could have gone down 3, and then I could have gone left 4. Those are both negative directions, but a negative divided by negative is a positive. So for our class purposes, I'm going to have you plot 3 points for a line. And you do need a straight edge, so if you don't have a ruler, it doesn't have to be anything fancy. Many rulers you can get for free. Sometimes office supply stores just have rulers. If they're not free, they're very cheap. You need something to draw straight lines with, because I am going to be particular about drawing straight lines, especially as we look ahead to solving systems of linear equations. That's going to be even more important. So there's our graph for this first example, y equals 3/4 x. So let's try another example. Here's another equation that's given to us in slope-intercept form, y equals mx plus b. So just a quick analysis. I noticed that the b, or the y-intercept, is 2. And so on the y-axis, remember, this number always gets plotted on the y, never gets plotted on the x. On the y-axis, I'm going to make a dot at positive 2. And from that dot, I'm going to count out the slope, rise over run. Well, this is a negative fraction. So you can think of it as either negative 3 over 4, or you could think of it as 3 over negative 4. Either way, it represents negative 3/4. So do you want to go down 3 and right 4? That would be certainly okay. Or maybe you want to go up 3, which is positive, and then left 4, which is negative. Either way is permissible, as long as you come up with 3 points for your line and connect your dots with a straight line. And there's the line for the equation y equals negative 3/4x plus 2. Okay, this equation is in what we call standard form. So we've taken a look at 2 examples with slope-intercept form. So just let's refresh your memory on what standard form looks like. It's some number times x plus some different number times y equals the constant c. So you can see that this red equation follows this pattern. Now I get that this says subtraction, but remember, subtraction could be represented by adding a negative number. So in general, we say this is what standard form looks like. Well, I'm going to give you really 2 options, and you can decide. I think it's good to be exposed to various ways when there's more than one way. Let's just get used to all of them, and in some cases, a certain method is better than another method. Even though they're both correct, it's always good to have options so that we can choose the best particular option given the problem. So here's a way, if I'm given standard form, here is one way of going about graphing it. I'm just going to leave it in standard form, and I want you to think about just temporarily just putting your finger over, just hiding the y term. Just pretend like it's not even there. Okay, so this y term is gone, and what's left is the equation 3x equals 12. And I think it's pretty easy. If we solve that equation, 3x equals 12, we would get x equals 4. Well, that x equals 4 represents an x-intercept. So I'm going to put a dot at x equals 4. Okay, there's the x-axis. There's 4 on the x-axis. Okay, so let's back up. Go back to our original. So far, I've created an x-intercept, x equals 4, and now I'm going to do the same thing with the x term. I'm just going to put my finger over it, cover it up. It's almost like it just disappeared, and I'm going to solve the equation that remains. Negative 4y is equal to 12. Well, that's pretty easy. If I were to solve this equation, I would get y is negative 3. That represents a y-intercept. So I'm going to plot negative 3 on the y. So what we've just done is a method called graphing by finding intercepts. And that's useful in cases like this where I have standard form. And not only that, but another thing that makes this kind of nice is you'll notice that both of these numbers divide into 12 evenly. So it's not always the best practice to just jump right in to solve by intercepts, but if you recognize that, hey, I've got a couple of numbers here that both of them divide into this constant, then I think graphing by finding intercepts is pretty easy. And then I've got 2 points, but remember we said we need a third. Well, let me show you a little fast, easy way to determine the slope if you're looking at standard form. Okay, so if I'm looking at slope-intercept form, finding slope is easy. It's just whatever that number is in front of x. But that's not true when I'm looking at standard form. I can't just say whatever's in front of x is the slope. When you're looking at standard form, you have to do this little technique, And we're going to take this number that we call A and put it over this number that we call B. But here's the trick. You got to remember, we're going to do the opposite of whatever that fraction is. Okay, so from standard form, in this particular case, my slope is going to be the opposite of negative 3/4, which we know, of course, is positive 3/4. Okay, so you could have also determined that by looking at these 2 points, up 3, right 4. But I do want you to know this little technique in finding slope without having to change this into slope-intercept form and then looking at that coefficient of x. I think if you get used to it, it's fast, it's easy. I've seen some standardized test questions that are, what's the slope of this line in standard form? And when time is of the essence, it's much faster to know this little technique than it is to solve for y and then look at the number in front of x. Okay, so we're ready to graph. I've got my 3 points. Let me just go ahead and do one more, like a running start here from my graph. And there is the line 3x minus 4y equals 12. Okay, here's another example of an equation, but it's not in either form. It's not in standard form. It's currently not in slope-intercept form. So I need to put it in one or the other. And it looks like for this one, it's better to just go ahead and subtract 7 from both sides and get this in slope-intercept form. Okay, and that was easy enough. All we did was one step. And so now we know in slope-intercept form, we can take a look at this constant, and that represents a y-intercept. So I'm going to go down to -7 on the y-axis, put a dot. And it's from this red dot that I'm going to count my slope of rise over run. Okay, so you can think of -2 either as -2 over 1, or you can think of it as 2 over -1. Both of those equal -2. And so I'd be fine if I counted out the slope as down 2, right 1. I'd also be fine if I counted out the slope as up 2, left 1. And so I've got my 3 points. And so here is my line. Okay, so sometimes it is necessary to do a step or maybe two to get it in one of the 2 forms, either slope-intercept or standard. Here's an interesting linear equation. It really is, it doesn't look like it, but it really is. You could consider this to be slope-intercept form. But what makes it a little bit odd is that the slope in this case must be 0 because we don't have an x term, which means we must be multiplying x times 0. 0 times x is 0. So in a way, we could have rewritten this using slope-intercept form as this. Okay, a slope of 0 line is always horizontal. Now I wrote this kind of weird on purpose. That is a y, but if you think about it, if you flip this over, it makes an h. Okay, and some people really struggle with lines that have y equals a number, and then our next example will be x equals a number. And some people really struggle with that. Is this a horizontal or a vertical line? Well, I'm hoping that this little trick, writing the y like this on purpose, will maybe help you remember, if you have trouble with it, that if you flip this over, it makes an h. This always represents a horizontal line. So I'm going to go to where y is 4. I'm going to make a dot. And then, since, remember, my upside down y is going to represent an h, which means horizontal, I'm going to make a straight horizontal line through that y-intercept. And I'm a little bit low for some reason. Let me try that again. Yeah, that's better. Okay, so there is the line y equals 4. Horizontal lines have a slope of 0, and we'll look at that in just a moment when we look at the equation or the formula that we use to calculate slope. So let's contrast that with equations like this. Well, we can kind of reason through that if we've identified these y equals a constant lines as horizontal, then x equals a constant must represent a vertical line. So we're going to go to -2 on the x-axis, vertical straight up and down through -2 on the x. So here is x equals -2. So there's a few people every year that really struggle with does this represent horizontal or vertical? Well, maybe if you can identify the y with this little trick, if that helps, then obviously that will help you identify the x because it's got to go the opposite direction. Okay, so far so good. Now, those examples will help you with problems 1 through 8 on the assignment. And now 11 through 19, we're just practicing, refreshing your memory on the formula that we use to find the slope of a line if we know 2 points on the line. And here's that formula you saw in Algebra 1. It's the difference between the y coordinates of the 2 points over the difference between the x coordinates of the 2 points. All right. So this x1, y1, all that's referring to is the order of these two ordered pairs. For example, the first x that I see is -2, and this would be the second x, the x1 and x2. And same thing here. If I'm just moving from left to right, this would be considered the first y, and this would be the second y. Two different y's, and we're just kind of using these numbers to indicate the order in which they appear. We've already mentioned slope as the change in y, or rise over run. The top number indicates up-down movement, and the bottom number indicates left-right movement. This is going to be more and more common for you as you get into upper-level math classes, so I want to introduce it to you. This is the symbol, the Greek symbol or letter delta. And delta in Greek literally means the change in, or you might just think change. So this reads delta y over delta x. The change in y, we find that change by subtracting the two y's. The change in y divided by the change in x. Okay? And I use this illustration. Some people flip these. I've seen this in Algebra 2 where people get a little confused and they put the x difference over the y's, and that's fairly common. So maybe this will help you keep that straight. If you think of the letter y and associate that with the question why, W-H-Y, okay? Somebody came up with this years ago, and I just picked up on it. I thought it was kind of clever. Maybe it'll help you remember that y goes over x, or the top of this fraction will be y, the bottom will be x. And somebody phrased it like this, thinking of the question why. You have to know the question, the why, before you can give the explanation. Okay, so that kind of gives you the order. You have to know the question, the why, and that's kind of a play on words, the why, before you can give the explanation. So if that helps, maybe you don't have any trouble with it, but over the years I've seen people that do flip that over, and maybe that little statement will help you keep that straight. All right, so now that we've established the formula, let's use it. So I'm going to take this second y, which is -5. I'm going to subtract the first y, which is 4. And below that, I'm going to take the second x, which is 3. And I'm going to subtract the one before it, which is -2. And you do have to be careful at this point because no problem on the top, that's -9, but remember what it means to subtract a negative number. And so that would be our slope, and we do want to leave these slope answers in improper fraction form. That just helps us when we're graphing to do the rise over run. All right, so that would be the answer for this example. I've got another example of this just for more practice. Now, you really, if you didn't exactly follow y2 minus y1, that's really okay. I mean, I really could start with this as my first y. I could do 7 minus -6, and that would be fine. But what's not fine is this, and I do see this happen occasionally. I can start with 7 on the top, but that means I've got to start with -2 on the bottom. Okay, you're going to mess yourself up if you start with this on the top and then you're not consistent and you decide to start with this on the bottom. Okay, so whichever ordered pair you start with, do the same thing on the top and the bottom. I started with the 7 on the y top side, so I'm going to start with -2 for x on the bottom side. Okay, and so this is 13 over -10, or -13/10. Okay. Now we're going to break this section up into two parts because there's so much involved, and so we're going to come back to this the next time we meet. But to conclude this lesson, we're going to look at problems 20 through 25 on page 68, but I'm changing the book instructions a little bit, so you need to, and I put this in RunWeb, you need to pay close attention to what's happening here. The book is going to give you the slope of a line. They're going to give you the point, a point in which, through which the line goes, and then they say to write the standard form equation. Well, instead of writing the standard form equation, I want you to write the slope-intercept form. And as a reminder, again, here is slope-intercept form. Okay, well, this is not going to be too bad because with what I'm given, remember slope is identified in this equation by the letter m. So basically they tell me what to put in for m. When they give me an ordered pair like this, the first number in the ordered pair is x and the second number is y. So they basically told me numbers to plug in for x and y. The only number that I don't have to plug in is I don't have a b. I don't have a number to plug in for b. So using these three numbers plugged in for these variables, I'll be able to find b. Okay, so let's just substitute. Y is 5. The slope, m, is 3. The x-coordinate of the ordered pair is 1. And this is going to be pretty simple. Solving for b, I'm going to subtract 3 from both sides, and I have b. Well, to write slope-intercept form, I basically need to know two numbers. I need to know the slope, which I'm given, and I need to know the y-intercept, which we just found. And so that makes writing the equation in slope-intercept form pretty easy. And so here will be my answer, 3x plus 2. Okay, so just remember when you're writing slope-intercept form, you're looking for a number to put in for m, and you're looking for a number to put in for b, and you'll have to solve for that. The y and the x remain variable. All right, let's try another one of those. Here's another example, and again, we're doing the problems 20 through 25, and we're going to put our answer in slope-intercept form. We're ignoring the book instructions for this section. So here's slope-intercept form again. Again, the slope, m. Here's an x. Here's a y. So let's start substituting. Y is -4. M is 3. X is 9. I get -4 equals 27 plus b. I'm solving for b, so I need to undo adding 27. And I get negative 31 equals b. Well, remember, when I'm writing slope-intercept form, I'm really needing to replace two of these variables with actual numbers. I need to replace m with a number, which is going to be easy because we're given that. And now I can replace b with a number because we just found it. So here's my final answer for this problem. Y equals 3x, and then you could do plus negative 31 if you like. I'm just going to do minus 31. All right, and so that would be my answer in our changed instructions using slope-intercept form. Okay, so we're going to call this section 2.2 part 1, and that will take care. I've given you enough to help you with tonight's homework. Check RenWeb for the assignment for tonight, and then when we meet again, we're going to consider the rest of this section as part 2, and then we'll have a different assignment after that lesson. So let me know if I can help. Have a good day.